Antimicrobial agents pervade our lives. Soaps, scrubs, cosmetics, the things we touch, and the water we drink often contain or have come into contact with antimicrobials. Two similar antimicrobials of concern are the co-occurring organohalides triclosan, abbreviated TCS, and triclocarban, abbreviated TCC. These polychlorinated aromatic compounds can be found in deodorants, shampoos, skin lotions, bar and liquid soap, sanitizers, mouthwash, toothpaste, cutting boards, furniture, and a great many other products. Soaps are particularly concerning in regards to TCS-TCC use. A 1999-2000 US study found 76% of liquid soaps and 29% of bar soaps contain TCS or TCC. The TCS and TCC from these products ends up inside people. An examination of breast milk from California and Texas found 60 out of 62 samples contained TCS, at concentrations up to 2.1 milligram per kilogram. And of 2,500 US urine samples, 74.6% contained TCS at levels up to 3.79 milligram per kilogram. Organohalide present in such levels in such a large portion of the population definitely raises questions as to what effects it may be having. In recent years, the endocrine disrupting properties of several commonly encountered chemicals, such as BPA, have become a public concern. Evidence suggests TCS and TCC may also have endocrine disrupting properties. In medica fish, TCS was found to increase liver vitellogenin concentrations. Vitellogenin is an egg yolk precursor protein not normally found in significant quantities in unfeminized male fish. In immature female rats, exposure to TCS increased uterine weight compared to a control. Young male rats exposed to TCS over the course of 60 days exhibited decreased blood concentrations of luteinizing hormone, follicle-stimulating hormone, and testosterone, in addition to testicular malformations. TCS has also been found to displace estradiol and testosterone from their respective receptors in vitro. In a study of several suspected and confirmed endocrine disrupting compounds, TCS was positively correlated with aeroallergy sensitivity and food allergy. Interestingly, only the antimicrobial endocrine disruptors tested showed a significant correlation with allergy, suggesting an antimicrobial rather than endocrine disrupting basis to the allergy effect. Research in fish, rats, and in vitro studies indicate endocrine disrupting effects. In people, however, more research is needed in order to reach conclusions on the endocrine disrupting potential of TCS and TCC. Of additional concern is the issue of cross-resistance of pathogens to antibiotics. Developing antimicrobial resistance to one substance can often lead to resistance to other antimicrobial compounds. For example, sublethal concentrations of TCS, like those concentrations found in the environment after consumer product use, have been found to confer resistance to the antibiotic isoniazid and M. smegmatis bacteria. TCS disrupts fatty acid synthesis by inhibiting the enoyl acyl carrier protein reductase. If a mutation of the FABL gene that codes for this protein causes TCS resistance, it may also reduce the effectiveness of other drugs that inhibit this pathway. Another way TCS can cause general resistances is through its action on efflux pumps. In bacteria, efflux pumps remove many things from the cell, including toxins, and are often nonspecific. It has been shown that TCS presence upregulates the expression of these efflux pumps, causing other antimicrobials to become less effective. When TCS-TCC enters wastewater treatment plants, the high number of bacteria present there and their importance for waste treatment create an environment ideal for the induction of resistance to antimicrobials present in wastewater. This general resistance is concerning given the extent to which TCC exists around us. Something meant to kill bacteria may be making some of them stronger. Wastewater discharge means TCC-TCS is commonly detected in many aquatic compartments. TCC-TCS appears to more greatly affect organisms at the bottom of their respective food webs. Algae in particular are sensitive to TCS-TCC exposure. In several algae species, their populations were experimentally found to decrease significantly in response to TCC or TCS exposure. On land, TCC and TCS is often introduced to the soil via wastewater treatment plant sourced biosolids. Some species of earthworm and the birds that feed on them have been found to have high TCS or TCC concentrations. A further concern are the photochemical products of TCS and TCC. Chemically, TCS and TCC look similar to the more harmful dioxins. Indeed, TCS can be photochemically converted to several polychlorinated dibenzodioxins. TCS, upon entering wastewater treatment plants, is further chlorinated. Once in the environment, this further chlorinated TCS then photochemically reacts to form a range of dioxins. Sediment cores from several sites in Minnesota and Lake Superior indicate that TCS and TCC represent the primary source of these dioxins in the water after the year 1965. Considering the potential negative effects of TCS and TCC, what regulations exist in regards to their use? In Canada, TCS concentrations are limited to 0.03% in oral care products and 0.3% in cosmetics and soaps. As of December 31, 2014, TCS is no longer allowed as a pesticide for material goods in Canada. In the U.S., regulatory responsibility of TCC and TCS lies with both the Environmental Protection Agency and the Food and Drug Administration, but little action has been taken to date. So what benefit is there to TCC and TCS containing products? In a healthcare setting, these products show evidence of usefulness. In addition to being gentle on the skin, a 2% TCS solution was found to inhibit the growth of Staphylococcus epidermidis and Staphylococcus aureus better than a 4% chlorhexidine solution. In regards to consumer use, however, a 2007 meta-analysis showed no significant benefit to the 0.1% to 0.45% consumer TCS soaps over normal soap. Exposure to triclosan and triclocarban won't turn you into a horrible disease-ridden, feminized, allergy-prone ghoul, but their likely negative effects on endocrine function, increased antibiotic resistance, and ecological downsides, combined with evidence that their use may provide no benefit at the consumer level, indicates that research into a consumer-level ban is warranted.